Okay, welcome all. So today we will be solving another problem from the TIFR question paper 2019. So this question paper, especially 2019's question paper, was pretty. Uh, I mean, you can say fun to solve. Okay? Because it consists of challenging problems as well as simple, tricky problems. Stuff like that. So this is one of the problems where you can find the trick if you understand differentiability pretty well. So see here the question, the function, the question that has been given to us is this precisely, that f of x is equals to x plus x square cos pi by x when x is not equals to 0 and 0 when x is equals to 0. Okay. So as you can see, the options, that are mentioned here is that f prime 0 exists and is equals to 1. It's not increasing at any neighborhood of 0. It does, f prime of 0 does not exist. It is increasing on R. So which of the following statements are actually true? So these are the collective MCQs that has been given to you. So the first thing, let us deal with the f prime of 0 case. So let's first assume. So let's assume that f prime of 0 exists. So then what should be its value? It is pretty 1. I mean, it's pretty trivial that you can actually compute its 1, because if you just take f of x minus f of 0 by x, limit x tends to 0, this will give you 1. So now if we do not assume that, if you go from the very beginning to try to solve it, it's like this, that what is my f prime of x? So my f prime of x is f of x plus h minus f of x by h. That's it. So what is f prime of 0? How will it be? So it's practically like this, f of h minus f of 0 by h, limit h tends to 0. All right. So this is how the f prime of x. So if this exists, then f prime of 0 exists, and whatever the value of this function is, it will be the f prime of 0. So if you look at it, what is this? So this function is nothing but h plus h square pi by h by h. So this is nothing but 1 plus h cos pi by h. So which is, you can actually write it like this, 1 plus cos pi by h divided by pi by h into pi. So now since limit h is tending to 0, so here you can actually apply that limit 1 by h tends to infinity. So if 1 by h tends to infinity, then this, by the formula of limit, will automatically go to 0, because if you have cos x by x, limit x tends to infinity, this is always 0. You can actually prove it by sandwich theorem. All right, because cos x by x, it will always be less than or equals to 1 by x, and it will always be greater than or equals to minus 1. So by the sandwich theorem, you can always prove it. So that is how it goes to 0. So the leftover is 1, and hence if prime 0 exists, and the derivative, the f prime 0 is 1. Okay. So so if you have any questions, just put down in the, after the discussion of these, after the discussion of solution, I will get back to those questions. So now that is there. So from here, what we can have, we see that f prime of 0 exists, and is equals to 1. So out of all these four MCQs, the first one is correct. The first one is correct, and thus of course, obviously, the third one is incorrect. Okay, so from here, what are the possible choices for this answer? It is either 1 or 2. So as you can see, how many of the above statements is or are correct. So since one of the statement has been correct and another statement is wrong, and as you can see, the rest of the two statements are either it is increasing at a neighborhood of 0 or it is increasing on the entire R. So these are the two leftover options. So now we will actually use the Taylor's formula, the differential Taylor's formula for the cos-x, and we will see that why it is increasing actually. Okay, so if you use Taylor's formula, the cos of x, it has a power series form of like this: x square by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6, and goes on so on and so forth. So what we have been handed is cos of pi by x. So what will happen? So this is 1 minus pi square by x square into 2 factorial plus then you have pi to the power 4 by x to the power 4 into 4 factorial, and it goes on so on and so forth. So the function that has been given to us, is this: x plus x square cos pi by x. So now if you look at this function, how does it look like? So it practically, now if you just expand it in this power series form, it practically looks like this: x plus x square minus pi square by 2 factorial plus pi to the power 4 by x square 4 factorial minus, and goes on so on. All right. So now as you can see that this is the function that we have. So if you have x1 greater than x2, it's quite clearly you can see that this will be, I mean, this is an increasing function because of this first part. The rest of the part will take care of themselves. The alternating sums will take care of themselves. I mean, in a pretty same way. So you can actually prove it like this: that x1, this, so let me call this as f of x. So then f of x1 greater than f of x. So you can follow it, and you can just put down the x1, x2, and see how they're working coefficient wise. That is a very valid way. Otherwise, what you can actually do is you can actually take the f prime of x. So if you take f prime of x, as you can see, what happens is that this becomes 1, this becomes 2x, this goes away, and then everything that you have is minus of something which are always lesser than 1 plus 2x. So if, because since you have x square, then if you take the derivative, it will be minus of 1 by x cube into 2. I mean, like, it's basically x to the power minus 2, right? So how will it happen? So it is minus 2 x to the power minus 3. So then, so the rest of the things that you will have, it will always be in the negation. Okay, so which you can actually control from this by this 1 plus 2x version. Okay, so the moment you control it from the 1 plus 2x version, you now can show that will this be will it be increasing or decreasing. Okay, so in this case, whenever you have a neighborhood, which is in the positive directional setup, and you take a neighborhood of 0 which has radius more than 1, there it is always increasing. Okay, so hence one of the options that you have here is not going to work. So f is not increasing in any neighborhood of 0. So this is something that you will see once you go through this Taylor's formulation and put down whatever you need to write. So the answer to this question is that hence, since I have it as an increasing function in some separate intervals and it's been proved, so what I have in my hand is that here there are two statements which are true. Okay, so the first thing is that f prime of 0 exists and is equal to 1, and the fact that f is an increasing function. Okay, so if that is what we have for this problem, let me answer Anil's question. So, do you teach JEE Maths? So right now, I do not. Uh, so from Cheenta, we do not have an IIT JEE. I mean, like JEE patterned maths course, but yes, there are people who are teaching the Olympiad level mathematics, and I think you can actually join there. There are level 4, level 5 problem solving sessions, and it's a pretty well structured coursework for the +2 level students who are preparing for ISI and CMI. So my section is the uh, college mathematics portion. So you once you're interested in higher mathematics, then probably you will if you join Chinta, then we will probably have an interaction. Okay, so that's it for today. Thank you for joining. We will meet next time.